Dear students, today I am back with the next episode of Ellipse, the basic introduction to Ellipse. And the first thing that we are going to prove here is to prove that PF dash plus PF is equal to twice of A. What is P? P is any point on the ellipse. And what are F dash and F? They are two of the foci of the ellipses. Yesterday we just read about this property. Today we are going to prove it. Okay. So let us do it quickly. This is an ellipse. Okay. This is an ellipse and the standard equation is x square by a square plus y square by b square is equal to 1. So let us draw the axis. Okay. Now this is a standard equation, a standard ellipse x square by a square plus y square by b square is equal to 1, and such that a is greater than b. Such that a is greater than b. Now what we need to prove? We need to prove that if I am taking any point on the ellipse, if I am taking any point P on the ellipse and I am measuring its distances from two of the foci. Okay, this is one of the focus F dash and this is one F. So I am saying that PF plus PF dash is equal to twice of A. We need to prove it, right? Now what I will do? I will draw two of the directrices. Okay, two of the directrices. So one may be here and one will be here, right? These are two of the directrices. Now what I will do? I want to measure the distance. I want to measure the distance. So P, this is a perpendicular and this is another perpendicular. Okay, this is another perpendicular here, right? Okay, let us name these particular points as Pn and Pn dash. Okay, let's rename name these points as n and n dash. Now, by the definition of ellipse, we know that Pf upon Pn is equal to E. Yesterday I taught you the definition. So from here I can write Pf is equal to E times of Pn. Now coming to the second part, Pf dash can be written as E times of Pn dash, right? Now adding the left hand side of both of these equations, so Pf plus Pf dash is equal to E times of Pn plus Pn dash. Am I right? Now what is Pn plus Pn dash? As you might be seeing that Pn plus Pn dash is equal to n dash, and which is parallel to the x-axis. Okay, so it is nothing but it is just the distance between the two directrices. So what was the equation of this directrix? It was x is equal to a upon e. And what was the equation of this directrix? It was x is equal to minus a upon e. So if someone tells that what is the difference between these two directrices, it is nothing but 2a upon e. Therefore I am writing it as e times of 2a upon e, and therefore this is equal to twice of a, and hence it is proved. I hope you might have understood this proof. Now coming to the next part. What I have written here is the equation of tangent to curve at a point Px1 y1 is equal to xx1 by a square plus y1 by b square minus 1 is equal to 0. What is the curve? The curve is an ellipse. The second equation is the equation of tangent to curve at a point whose eccentric angle is phi is x by a cos phi plus y by b sin phi is equal to 1. And the third thing is equation of tangent to curve whose slope is n is given as y is equal to mx plus minus root under a square m square plus b square. So let us see these 3 points. Okay, let us see these 3 points. The first one says that if there is an ellipse, and if a random point is here x1, y1, and I want to find the equation of tangent drawn at this particular point. It is very easy. How we will find? First of all, by calculus, we will find the slope at point x1, y1. So, if the curve equation is x square by a square plus y square by b square is equal to 1, then we will be differentiating both the sides. Okay, so twice x upon a square, how it came? By differentiating with respect to x, plus 2y into dy upon dx upon b square is equal to 0. Okay, what I did differentiated both the sides with respect to x. Here we should write also that differentiating both sides with respect to x. Now from here I can write it dy by dx is equal to minus x upon y into b square upon a square. Okay, is this right? Yeah. So this is the general equation of slope. Okay, now the slope at, if I write here the slope at x1, y1, this means that I am finding the slope at x1, y1, then just replace x, y, x1 and y, y, 1. So the slope came. Now I have to write the equation of the tangent. So it is very easy. I can write it as y minus y1 upon x minus x1, and this is equal to minus x1 upon y1 into b square by a square. Right? Now just making some shifting here and there, like cross multiplication. So I will get y1 minus y1 square. Okay, and let us multiply this by a square, and this side minus x1 plus x1 square, right, multiplied by b square. What can be done? We can write y1 by b square minus y1 square by b square is equal to minus x1 by a square and minus x1 square upon a square. This can be written further like y1 by b square plus x1 by a square, and that is equal to x1 square by a square plus y1 square by b square, and that is nothing but equal to 1. Why? Because x1 and y1 lie on the ellipse. So the final equation that you are getting for the tangent is nothing but x1 by a square plus y1 by b square is equal to 1. This proves the first equation of tangent to the ellipse. Now coming to the second thing. Okay, now coming to the second thing, it is nothing but just an extension of this. What we studied, that the parametric coordinate of any point on ellipse, the parametric coordinate of any point on ellipse is given by x1 is equal to a cos theta and y1 is equal to b sin theta. All of you are remembering this. Okay, so I have just to substitute this. So x into a cos theta by a square plus y times of b sin theta by b square is equal to 1. So we can cancel both of them and we can write a and a square, b and b square. So we can write x cos theta by a plus y sin theta by b is equal to 1. So this proves the second equation of the tangent. I hope it is clear. Okay, this proof